Coming up on This Week in Radio Tech, we're talking to Kent Winrich about the relationship between wireless ISPs and their technology for bringing internet out to rural areas, and, of course, broadcasters who have towers in rural areas. It's all coming up next on TWiRT. This Week in Radio Tech is brought to you by Broadcasters General Store, with outstanding service, savings, and support. Online at bgs.cc. By Angry Audio. Audio problems disappear when you get angry at angryaudio.com. By Nautel, keeping you connected with your community with support and webinars. Online at nautel.com/webinars. And by Max Connect Wireless, prioritized high-speed internet service designed for transmitter sites and remote broadcasts. Hey, welcome into This Week in Radio Tech, the show where we talk about everything from the microphone to the light bulb at the top of the tower. I'm Kirk Harnack, your host, delighted to be here. And where's here? I'm not in the usual Telos Alliance studio. No, I've moved for the weekend. I am out on the East Coast at the Eastern Command Center. Well, you know what? That's not right. I think Chris Tobin has the Eastern Command Center for This Week in Radio Tech. I'm just near the beach. I'm in Charleston, South Carolina, at the home of my friend Roger Gaither, and glad to be just working remote from here. If you're going to work remote from home, you can do it from your own home or somebody else's home. So that's what we're doing. I do want to thank Telos Alliance, though, for being a part of the show and providing me an hour or two off on Thursdays to put this program together for you broadcast engineers. So anyway, here I am live on the air in Charleston, South Carolina, and also outdoors. Not only me, as our guest pointed out, but Chris Tobin is outdoors. Chris, welcome into the show. How you doing, man?
I'm doing well, thank you. Yes, it's a little overcast skies, but it's nice. Some nice diffused light, but things are good. The city is still in pause mode. I'm not sure when the pause button gets lifted, but sometime in the next 2 weeks, I think. I can't get a straight answer from anybody. But that's about it.
We did a little running around here, doing some shopping and getting ready for this show and doing some things for Telos, and noticed that some retail outlets fully open, others like Best Buy. You can't go in the store, but you can stop by and tell them what you want, and they'll bring it out to you. So that was interesting. We went to Popeye's Chicken and had one of their spicy chicken sandwiches, and only 3 customers in the store at a time, just 3. So I left my friend outside. And I went inside and ordered chicken sandwiches. It's interesting getting back to normal. But traffic, though, is just about back to normal. Traffic, at least here in Charleston, almost up to as bad as it ever is. I guess New York City traffic, though, is still pretty light, huh?
Oh, yes. I'm looking down now on the avenue, and 1, 2, 3 cars. And it's 5 o'clock in the evening.
Oh, wow.
On a Thursday. That's usually not the case.
Oh, wow.
No, things are shut down. Best Buy, you could, up until about 8 weeks ago, you could call in, go up to their door, and they'd give it to you. Then something happened, and they were told they can't do that anymore. And then everything went south. So a few places are starting to open up, but it's kind of weird. I'm not sure what's going on with the local authorities and what they interpret as what's okay and what's not. And the businesses are going a little batty, trying to figure it out, too.
Well, Best Buy's interesting policy is apparently the same here in Charleston as it is in Nashville. I haven't been to the Best Buy in Nashville, but I did drive by it, saw some signs, and they were identical to the procedures they're following here. But you can go into Lowe's or a Walmart and shop as normal. Some Walmarts are limiting the number of people in the store, but it's not hard to, as soon as somebody pops out, you go in. So, I don't know. We'll see what happens when it's all over. I have my own opinions, but I pray for the authorities. How about that? Just hope they do the right thing.
It's going to be a lot of praying and no Venus.
Yeah, yes, it is. Hey, before we jump in and introduce our guest, I'm delighted to have our guest coming up, but in just a minute, we'll introduce him. I want to remind you or tell you about the things that Nautel is doing. Nautel recognizes that engineers like us we're busy, but sometimes we're also home. And so they've put together a whole series of webinars on some great topics. And Chris, the next one coming up is going to be on Tuesday, June the 2nd at noon Eastern Time. Tuesday, June 2nd at noon Eastern Time. June 1st marks the official beginning of the Atlantic hurricane season. So there's possibly, of course, for hurricanes, typhoons, monsoons, winter weather if you're on the other side of the world. And coming up Tuesday, June 2nd, host Jeff Welton and special guests Jason Garoditzer and Shane Tovin. Now, Jason's with iHeart, Shane's with EMF. They're going to be Jeff's guest, and the topic is going to be storm season. And weathering storms, getting your transmitter site ready for storms. So you want to sign up for this thing. It's things you should do to prepare your sites for various seasonal challenges, firsthand experiences, and believe me, both Jason and Shane have experience, and Jeff's been around too. I mean, he's been to plenty of transmitter sites before and after storms. So learn of their firsthand experiences, how they've adapted, and how they've overcome when you do suffer damage. I mean, try not to get it, but if you do, what are some things you can do to get back on the air safely and covering your service area as well as possible? Chris, if you want to sign up for this, go to nautel.com/webinars. That's nautel.com/webinars. We'll have a link for this also in the show notes. So if you're driving right now, and if you can't just go to that website right now, go to our website, thisweekinradiotech.com. By late tomorrow, we will have that link on there that you can go to at nautel.com/webinars. Coming up in June, there are 5 Tuesdays in June, and Nautel has webinars each Tuesday in June, the 9th, the 16th, the 23rd, and the 30th, in addition to the one that's coming up a week from last Tuesday. So this coming Tuesday. So you don't forget it. Hey, it's next week. So don't let the weekend go by and let that erase your mind. Put this on your calendar for noon Eastern time from Nautel, but go register first, nautel.com/webinars, and they'll send you an email and get you all set up. Chris, I'm looking forward to that one. Anytime Jeff Welton is on and has guests on, it's a worthwhile endeavor.
Absolutely. He's got some good guests. I mean, even between Shane, Jeff, and Jason, forget it, it's going to be a good time. It's well worth it. It's a good lunch hour. You know, you break out a sandwich, a nice adult beverage or not, and then enjoy an hour of fun. And Jeff will definitely entertain very quietly and very, how would you say, his sharp wit or dry wit at times is perfect for certain things like this. That's all I'm going to say.
Jeff is able to use his wit to drive home very valid points. So
absolutely
good time. Hey, okay, let's bring our guest in. Kent Winrich is here, and Kent and I have known each other on Facebook for a long time. Kent, welcome into the show. How are you, sir?
Thank you. I'm doing great. How are you?
Terrific. You look great. You must be in your ham shack.
Ham shack, office, lab, guitar place. I don't know, a little bit of everything.
So you work with this company, Open Internet?
Open Broadband. Yes.
Open Broadband. Okay, and you're the Chief Technical Officer, CTO.
Yes, I am.
So Ken, I got to tell you, most of my radio stations are in Mississippi, and the availability of broadband is pretty limited, especially at our transmitter sites. I mean, it's bad. There's just no hope of getting even DSL to some of our sites. And you're in North Carolina. You've got a lot of rural sites in North Carolina too. So in the coming hour, I want to talk with you about the synergistic relationship that broadcasters should be having with their wireless ISPs. Sound like a good idea?
Sounds like a great idea. And also, actually, we've known each other before Facebook. We've known each other since NAB, since I used to work for the Clear Channel back then in Milwaukee. So,
yes.
Been going back quite a ways.
Oh, yeah. Oh, my gosh. Wow. You and I have been doing this a long time, haven't we?
Indeed.
Okay. And I got more topics to talk about too with wireless ISP. So Kent's coming up. He's a CTO at a wireless ISP. So you're going to hear information from the horse's mouth. And Kent's been in broadcasting too. So that's super. Hey, right now I want to mention to you our sponsor, Angry Audio, and I brought with me here to the East Coast. I brought with me some show and tell items. This is one of my favorites right here. This is the Headphone Gizmo from angryaudio.com. What's cool about this is the sexy curves on it, because you won't be snagging your pants or your pantyhose on these sexy curves. This mounts underneath your audio, your tabletop, right? You can screw it in. It's also got little rubber feet on it, so when you screw it in, it's nice and quiet. Right? You can lay it on top of the console if you need to, so you can move it around if you have to for guests and so forth. And the rubber feet just keep it stuck, where you put it, so you can plug into it. You can turn the volume up and down, and it won't just slide across the desk. On the back, it's got room for the power to go in right here, or you can power it using the Studio Hub standard right here. Audio in and power in can go out. And if you power one of these, if you power one of these, then you can also daisy chain that power to other units, as well as the audio. So daisy chain it just with Cat5 cable using the Studio Hub standard. That's the Headphone Gizmo from Angry Audio at angryaudio.com. I also want to remind you that if you order my favorite cable adapters, these Studio Hub adapters, and they're making the original The high quality Studio Hub adapters in the same factory where Radio Systems made them. Studio Hub adapters. Get them with the female RJ45. You're going to need a Cat5 cable. And if you ask for yours, you get them free for every one of those cable adapters that you buy with a female RJ45. Tell your dealer, I want my free Cat5 cable, and they will have to include it because you asked for it. But that's only available as a TWiRT special. So you don't have to mention TWiRT. You're welcome to. Love it if you would. But you get a free 7-foot shielded Cat5 cable, and the label even has the proper pinouts on it in case you need to know that for Studio Hub. So thank you so much, angryaudio.com, for sponsoring This Week in Radio Tech. Check out the whole line of gadgets and gizmos that they have, that they build for you. Broadcasters building for broadcasters at angryaudio.com. All right, Kirk Harnack, Chris Tobin is along here, and I'm looking forward to a good 45 or 50 minutes of conversation with Kent Winrich. So, Kent, why don't you start out and tell us a little bit about, we've talked about wireless ISPs once before on the show. Patrick Parks was a guest some years ago, but tell me about the wireless ISP service and business, and just generally, what are you doing for people who need internet?
So we're trying to get broadband to areas that typical providers, the Comcasts, the Spectrums, the AT&Ts of the world won't go to because of there's just not enough density of people. And so it's really easy to deploy wireless, much quicker to deploy wireless, and you can get surprisingly very good results out of wireless. We have a couple of customers, for example, that are doing full gigabit wirelessly, and we have a link that's wireless 5 gigabit. That's not your normal connection, however. Normally, we're looking at just trying to at least get the minimum broadband of 25 down, 3 up, and but a lot of our customers are 100, 200 megs or better. But when we get into the real rural areas, we're utilizing LTE and the 3.5 gigahertz band, and that gives us non-line of sight penetration to trees and vegetation and the like. So we can really reach a lot of people utilizing LTE, and I'm sure a lot of people have heard about CBRS, and also there's been the big discussion about C-band as well. But CBRS is kind of our big topic right now. So that is where the AT&Ts and Verizons and the like are going to be able to get in on the 3.5 gigahertz band. It's all controlled by something called a SAS, so that each one of these, they're called eNode Bs, they're access points that are on the towers, are controlled by a company like Google, so that if there's interference, Google can adjust our transmitter settings and change the frequency and the like, and make sure that people aren't interfering with each other. So it's a lightly licensed area. Presently, we're running everything from, we do run a little bit of 900 megahertz, which is very rare. It's mainly in the very rural areas. That's kind of legacy stuff. We run a little bit of 2.4. Definitely a lot of 5 gigahertz, 11 gigahertz. I mentioned 3.5 gigahertz. 11 gigahertz is licensed. We run 24, which is unlicensed. We do 60, 70, and 80 gigahertz as well, which is lightly licensed. So we're kind of all over the whole arena there with different bands that we utilize, all providing a different type of service and different range and different types of connectivity. So we're trying to get back into these rural areas, maybe doing like a hub and spoke situation, and this is where towers are very important to us, or we call vertical assets. Vertical assets in some areas are just, there's nothing there. So we're utilizing silos, church steeples, a little bit of whatever we can find that's tall. And so anytime we can get a tower where it's like, yes, let's get in there and see if we can talk to people. We already have agreements with some FM stations that we're going to be able to get on their towers in very rural areas. That's going to be very helpful, and we're looking at possibly getting into some of the AM stations, because we just need to get into some areas that there aren't any other towers, and we just aren't any other options.
Boy, you really gave me a lot there to unpack, and Chris, please feel welcome to jump in too. But so I'm curious about a few things. I'm familiar with a wireless ISP in Mississippi that my radio stations have a great partnership with. So they have access actually to every one of our towers, and we get we trade for advertising to get broadband service at the different towers. And I'm surprised at how nimble this company is. And I've seen your posts on Facebook. You guys seem very nimble too, and you also looks like you have to get involved politically a little bit. I'm going to get the technical stuff in a minute, but it sounds like you sometimes have to go into a city council and persuade them to, I don't know, let you in. What kind of political things do you have to overcome to get broadband into an area?
That opens up a whole new avenue. Well, locally we work with typically counties. We'll work with counties because they seem to have a little bit of budget to be able to help to get some seeding money for us to be able to deploy. And typically counties also have communications towers as well. So they allow us to get on their communications towers, which makes life very easy. We also work with the state. The state has some grant dollars that we like to try to utilize. The state also tries to put together broadband plans for helping local governments, local counties. With the cities and the towns, what we do is we help them with providing like Wi-Fi in a downtown area and broadband for their downtown people. And if they have specialized connectivity needs, such as the real super high, gigabit or 5 gigabit connectivity, we can provide them with that connectivity or a backup solution for somebody who is got to have mission critical connectivity. We have one customer that paid for a full license link, even though it's only 300 feet, just so we can provide them a link that didn't touch their campus and provided a different access route, a non-pinch point fiber route, and that wasn't going through their parking lot. So, there are a lot of specialized needs. And then,
I'm sorry. Go ahead.
I'm sorry. And then also, I'm director of WISPA, the Wireless Internet Service Provider Association for North Carolina. And so I get involved with some of the federal things, going into D.C. and working with some of our congressmen and the like. So there's a lot of politics that get involved because the politicians want to get involved in broadband, the FCC and the like as well. For example, we had a couple of the FCC commissioners come and visit us out here, which is always great to have that happen. And we just it's nice that they're seeing what's going on with broadband in the rural areas.
So, Kent, you're a technical guy and we're a technical show. I would be curious if you would kind of walk me through from wherever you get backbone from, what does a typical deployment look like from starting from your provider, level 3, AT&T, whoever it may be, and then how you spread that out into your various areas. I'm guessing the farther away that a customer is, if you're 7 towers hops away, things could get a little dicey. So kind of walk me through that. And what does it look like for a typical customer?
Sure. So we try to have everything based out of a data center. Typically, we're running out of Charlotte right now. We're doing another data center. We're just about to stand up in Raleigh. And what we do is we do dark fiber from our data center to the area that we can get to. So typically, there's only 1 or 2 fiber providers in that area, but it's dark fiber going all the way back to our data center. And we will pick whoever we can get to provide fiber to us at our main hub in that vicinity. Once it gets to our data center, we have BGP routing that allows us to automatically choose between 12 different internet providers. So if there's a problem with XYZ company, ABC company can take over and slide right in, and it's all automatically routed within the data center. The big advantage to utilizing this type of system is that we're not applying internet out in the field. So when you apply internet out in the field, you end up with a lot of latency. We're trying to minimize latency. So dark fiber back to Charlotte is real close to the backbone, and we will be able to provide, like 7 millisecond ping time out in the middle of a cornfield in Eastern Carolina. So it's exceedingly fast, and when you do video conferencing and the like, or gaming, people really notice a big difference in the speeds. Even though our speeds may be a little bit lower than 300 meg, it feels faster and it operates faster because of the latency, the low latency that's involved in providing a connection like that. Once we get to a hub area in a town or a county. Fiber goes there, then we have a basic a core router sitting there, and then we will microwave out to multiple towers from that point. So we utilize everything again from 5 gigahertz, 11, 24, 60, 70, 80 to go out to these different towers, and then you can even distribute out further from there. I think the most hops we have is about 6, and we're still able to provide at least 300 megs to that tower, which gives people really decent speeds and very, very low latency. Out even 6 hops out, we're still sub 50 milliseconds in timing.
So if you're starting in some town and you've got fiber there that ends up dark fiber that ends up back in Charlotte, and so let's say that I'm this customer 6 hops away. Obviously, it seems to me you got to put your beefiest, broadest pipes, air pipes, IP radio pipes, from that point out toward that customer, because I'm sure you're getting customers along the way are picking off more and more speed. Do you ever just double up on have 2 parallel links to somewhere because you need more bandwidth there?
Well, in a sense, some of our radios are actually that way already. They're duplex. So they have, like our 24 gigahertz radios have dual dishes, and so they run duplex automatically. Or we can run a single dish and run split channel. We can do that even on 5 gigahertz. We can run split channel, so it's full duplex. So we don't need to put up multiple dishes. We just diplex into a single dish and just utilize different frequencies and different parts of the band to make that happen. So it's really much simpler than running multiple radios. We do run multiple radios in some very core areas that are needed, just in case there's a problem that one goes down. But I'll be honest with you, we've had so few problems, even with hurricanes coming through. We've been through 3 hurricanes already, and our biggest problem has been maintaining enough battery on our backup systems to be able to provide just enough power to keep things going. But we're going to start going to solar, and we do have portable generators that we keep in our staff's hands, so that if a site goes down and the batteries are depleted, they can just take out a little portable generator and bring it back up. But we try to be at sites that already have a generator backup where we can, but there are some sites that are literally in the middle of nowhere. For example, we had a crop insurance company that had nothing but a 3 meg DSL to their line or to their facility, and these are people that are taking phone calls and doing a lot of database work and the like, and they stood up a tower for us, a 120-foot tower, and we put our radios on there. We give them service, and we provide service to their neighbors throughout their neighborhood, out to about 3 miles or so. And so we'll work with people like that. But that's an instance where there's really nothing else out there. If all you got is 3 meg DSL, and it goes down a week at a time, their business is gone when that DSL is not working. So they're relying on us completely now.
How do you choose the IP radio's frequency band for a given purpose or a given link?
Throughput, ability to deal with weather, power, mainly throughput. We do a lot of 5 gigahertz work because it's unlicensed. And in the areas that we're in, there's not a lot of interference. If you go into a major city, forget it. It's not going to happen, or very little is going to happen. But I've got, for example, a 12-mile 5 gigahertz link that's pulling 300 meg right now, and it's kind of amazing. 5 gigahertz, you use that for your routers at home. Who would think you could pull off 12 miles on that? But it's serving a 240-foot tower 12 miles away, and it's kind of amazing what you can do with it. It's a lot of understanding propagation of different bands. For example, 60 gigahertz is very limited by oxygen molecules or humidity. However, 70 and 80 gigahertz can go further out because the oxygen molecules don't degrade the signal. So you can do like a kilometer in 60 gigahertz, and the radios are inexpensive, and I can do a full 2 gigs of throughput, or I can go to 80 gigahertz and do 2 miles and do 5 gigabits. So it's kind of patchwork.
Say, maybe you can help me understand something. The first 5.8 gig radio pair I ever put up was the pair from Ubiquiti. They don't make this one anymore, but it looks like baby's first microwave. I mean, it is so cute. It's just absolutely adorable. And I could not, I mean, it was so low. I mean, it's like Wi-Fi power, 5.8 gigs, and I had it going a 7-mile link. And I guess what I'm trying to wrap my brain around, and we'll get back onto some other stuff, but maybe as a ham radio operator, as an engineer, you can help me understand how is it that 5.8 gig has a trouble getting through 3 walls in my house, yet if I wrap a little parabolic dish around it, it'll freaking go, 7 miles with all the bandwidth I need to put axial live wire audio over IP on it with low enough jitter to handle that too. If I set everything just right, how does a parabolic reflector make it go from, literally 75 feet to 7.5 miles?
Well, a lot of it is to deal with the noise. If you could lower the noise, you get that delta that you're looking for, the signal to noise ratio. If you get good signal to noise ratio, you can do a lot. So we actually utilize horn antennas on 5 gigahertz, which completely eliminate the front to back ratio is pretty awesome. And it eliminates some of the side lobes. And these side lobes are, you've got those little nulls and the little tentacles that go out. That's a real pain when you're trying to put something onto, a beam with this wide, let's say, and if you got the side lobes, you could end up with a very poor signal to noise ratio. But I think it's a lot to do with, well, of course, it's focusing the signal. That pretty much is pretty clear that even aluminum chippy pop thing, or what they used in the old days, a Pringles can. That's hilarious. But just focusing it a little bit in a direction, but getting rid of some of the background noise and giving you better signal to noise ratios has been very helpful for us.
How do you handle the situation? And I realize you're using a lot of unlicensed. You're in rural areas. That's what we're doing with our private links in Mississippi, and that's what our wireless ISP is doing in Mississippi. As far as I know, all of theirs are unlicensed. As far as I know, they're all 5.8 gig area. What do you do when some interference comes up? Are your radios set to mitigate that automatically, or do you have to go look at things and say, I need to move it to here or there? How does that work out?
That kind of depends. There are some radios that will automatically move. I'm too hands-on, I guess, at least for now. There are tools built into the radios that will allow you to kind of search for the best frequency. So I kind of use a combination of the tools that are available to me. If I have a high-end link that I know has a good algorithm for doing automatic channel switching, I'll put it on that. Some of the other ones, though, I'll just go back and check periodically just to see how we're doing, or if I'm seeing signal levels starting to drop in a certain area, I'll just go back and adjust and change channels periodically. I monitor all of our devices either here or on the road, and I can see signal levels for every single radio that's out there on a single screen.
Wow. Chris has been quiet, and it's because I didn't see him raise his hand. Chris, you jump right in when you want to. Chris has a question. Go ahead, buddy.
There we go. Actually, early on, you talked about the different technologies that you use for providing services to customers and whatnot. And you mentioned LTE, and I know I've been following LTE outside of the wireless cellular industry and its uses. Which frequency range are you using the LTE technology in, or is it just you're using LTE through a local wireless carrier?
We're using LTE presently at 3.5. We have the ability to go to 2.5, but that's mainly taken by Sprint. But that's going to open up in the next year or so. We hope to see 2.5 open up. We're strictly on 3.5, 3.65 right now on LTE.
Okay, that's how you're using it to be able to do non-line of sight. Gotcha. Okay, gotcha.
Correct.
And Chris, I'm glad you asked about that. I was going to ask earlier, and so you prompted me to ask it now. Whenever most of us think of LTE, we think of phone carriers because that's how we see it used. But LTE is a technology that is applicable with your kind of deployments too, right? This doesn't necessarily mean Verizon or Sprint, right?
Correct. I mean, it's just a modulation and a provisioning process. Mainly just the modulation techniques, and so anybody can use it. Matter of fact, I could slide in one of our SIM cards into some of the latest radios that do have the 3.5 band, and I can actually operate data off a cell phone on our network.
Ah, okay. Wow. That's pretty cool. Okay. So now, do you in fact have some licensed links where you need to that kind of protection?
Yes, definitely. We've got some 11 gigahertz links. We've got some 80 gigahertz links. The 11 gigahertz are the big workhorses, and we share that band with a lot of the other big providers. But in the areas we're in, we typically don't have a problem getting those links up, and they'll do a full gig duplex on 11 gigahertz, which is really nice. But yeah, we try to get licensed links where it makes sense, because we protect ourselves from people interfering with us, and really it's. But as you build up, you start out with wireless links. You build that up until it kind of like gets tapped out. Then you start moving over into the license links, so that you can stay there forever. Then.
So my limited experience, 5 years ago, I put up some IP radios in the Mississippi Delta area to carry live wire to transmitter sites. It turned out to be a whole lot cheaper than us buying 950 megahertz radios like we traditionally would, and antennas for those, and half-inch coax for those. It turned out to be a whole lot cheaper, and we've been really happy with the way it's worked. We're delivering, bit for bit linear audio to the transmitter site. It goes right into the audio processors out there, and it's been great. And then at these sites more recently, we've received WISP service, typically 6 megabits down, 1.5 megabits up, but we've asked for more in a couple places just for backup. We can send coded audio to the transmitter site, decode it there, like our own web streams, and put them on the air if we have to, and we have done that when we've had a problem with the IP radio link. And my question was going toward this. I recently had to put up a little short hop with some Ubiquity products, about 1,000-foot path from one tower to another. Our WISP put their equipment on one tower, and we ended up needing service at the other tower. So I had to build a little link between them. But what I noticed was the software, the firmware that the newer radios had was, oh my goodness, so much more descriptive and telling of the quality of the link than just a bar graph. So tell me about the evolution of software in IP radios.
Well, it's kind of nice that the wireless manufacturers have taken something that has just been a Wi-Fi product and brought it up into something that you can actually engineer. There are a lot of tools available on the radios themselves to kind of tweak signal levels and monitor signal levels. It's gone from, here's your 3-bar signal level monitor to here's your signal to noise ratio, here's your error rates, they've got a lot of different items in there that help you adjust the radios for the maximum throughput. And the QAM rates have just gone through the roof. I mean, we've gotten over 2,000 QAM on some of these, and it's going faster and faster, even on the same channel. So their utilization of the frequencies has gotten a lot better. I mean, even in the last 2 years has gotten a lot better. We've nearly doubled in some of these areas. And but the firmware themselves it's kind of amazing, the tools that are available, that the things that you can see, the things you can monitor. And it's nice that you can do it all from your desktop. You don't have to go out to the towers all the time and adjust everything. We just do everything from a laptop or a cell phone now. But the firmware has come a long ways into making these radios much more productive and much speedier, and just really so much better for throughput on the radios themselves.
Kent, at least for the moment, looks like your picture's frozen up, and it's time for us to take a break anyway. So we're going to take a break, and we'll be right back. Our show, This Week in Radio Tech. I'm Kirk Harnack. Chris Tobin is here as well in downtown Manhattan, or wherever the secret place is that he broadcasts from. It's episode 495 of This Week in Radio Tech, and I'm here at on the East Coast. Chris is a couple hours flying time north of me, and we're just trying to enjoy being back out after being locked down for a while. This Week in Radio Tech is brought to you in part by our friends at Broadcasters General Store, bgs.cc. We'll be right back.
Yo, what's up? Live from NAB 2018. Hey, it's Caden. You need to check out Wheatstone and Vox Pro 7.1. The upgrades are amazing. If you're a jock, if you're a talent, producer, whatever, morning show, everyone knows Vox Pro, everyone uses Vox Pro, everyone loves Vox Pro. But now the features for this year, 2018, on 7.1 are amazing. If you're using version 4.5.6 and you go to 7, this is exactly what you're missing right here. The features are a game changer. It's going to cut down your editing time by like 80% depending on what you use Vox Pro for. And with version 7.1, introducing unlimited Practic button bars right here, hotkeys right here. I'm going to show you coming out of a song. Bad things. It's a lot of bad things that they wish and they wish and they wish and they wish. So you're coming out of your song? Yeah. Start your next song right here. It's basically an entire production room right on Vox Pro. So it's the Vox Pro we know and love with a ton more features. And now this is the ultimate game changer right here. Effect macros. So instead of hitting your effects button bar and going up here using your mouse for every effect, you do it right here with one click of the mouse, and you're going to cut down your editing time by about 80% without even touching this new sexy black controller. Check it out right here, Wheatstone Vox Pro 7.1 at NAB in Vegas 2018.
And we didn't go to Vegas this year, but Vox Pro is still there. And it's available at Broadcasters General Store, bgs.cc. Of course, you can give them a call at 352-622-7700. And I love these folks. They're such good. I was talking to Dave Kirsten just last week, and Dave and his whole family. It's a real family operation. And so you get people there that have a real good connection to each other and to the broadcasting business. Check them out. Broadcasters General Store. Thanks a lot for their sponsorship. I'm Kirk Harnack. Chris Tobin is here as well. And we're talking about wireless ISPs, Internet Service Providers. And I got to tell you, at my radio stations, it's been a godsend to have this extra path, or in many cases, the only path to get internet to a transmitter site. And so more and more, we're depending on wireless ISPs to help us out, either, Kent, either as a main and the only link we have to the outside world, or if we're in a decent situation, a secondary link. We can either carry parallel data through our wireless ISP, and maybe like at my stations, I've got a couple of transmitter sites where I made my own IP radio link, but I can't boil the ocean. I'm only so good of an engineer, and I really want a backup method for getting wireless there. Kent, earlier you mentioned from the data center and the dark fiber, you mentioned something about having a choice of different backbone providers. And I thought I heard you say something about a dozen providers. So did I hear that right? You can choose who's working well now? Okay.
Right. So we have a couple of vendors that we utilize, our core vendors for fiber or for internet, providing internet. But we have the ability within this data center to just automatically route, BGP routing. It will automatically route in case one link goes bad. The router will automatically route to a different provider, and it's completely seamless to any of our customers. And the data center that we're in presently has 12 providers. We've got one the one in Raleigh has 10 providers, and we're always looking to do more of a hotel situation to get more providers into that area so that we can have more services, more competition.
Here's something that happened at my WISP in the last couple of months. We had some really bad weather come through in January. A tornado knocked down one of our STL towers, for example, and did a lot of other damage. It seems that there was our WISP had to switch over to a different backup backbone provider for a while, and somehow they were able to keep giving us the same static public IP addresses. Am I imagining that, or is there a way to actually do that?
Yeah, that's part of the BGP routing. Now, that's magic that I don't get involved in. My network guy does that, and bless his heart, because I got nothing there. I just know it works, and he does his magic, and he says yes, it works. I go, good, it works, and we carry on. So I'm not a BGP programmer, and he is, and that's why he's on board. So. But also, we actually do provide service for a couple of broadcast stations, and we've actually become their main carrier because of our low latency. And there are many times where we're actually the only ones up, and the main, the cable provider, the DSL provider are the ones that are down, because we're actually putting battery backups in our hubs. And I mean, I have Spectrum where I live right here, and every time the power goes out, Spectrum's gone because they don't have battery backup, and so we have to go over to cellular at that point. But for our service, as long as you've got power at your end, you're going to have service throughout the storm, as long as we can keep the batteries and generators going.
You've already mentioned batteries and generators before, and just again now. And I think what's kind of amazing about the technology in this business is it doesn't consume a whole lot of power, unlike maybe a carrier cell site would consume a reasonable amount of power. I don't know, but you can describe what you got. At my WISP, not mine, the one that we use, the one we're partners with, they just typically have a fairly inexpensive battery backup unit at the base of the tower in a steel box. What's kind of standard equipment for you guys for battery backup?
Well, we like to put our cabinets full of DIN rail mounted power supplies and UPSs and the like, and then we'll use shell type batteries to. It's all we all calculate it out. Say, okay, we know that these radios together are X amount of watts, and we want this to last 2 days, and so we do a battery calculation to make sure that we're going to be able to maintain that level. It's kind of interesting, the access points, the 5 gigahertz access points that are broadcasting out to the customers runs about 5 or 6 watts. That's it. So it's very little. Yeah, and it's 24 volts PoE. We have other bigger radios, more powerful radios that are 30 watts. Our LTE radios are about 50 watts. There's a lot of processing going on in LTE, so there's a little more power hungry. But we're only putting out 30 dBm out of the radio, which is 1 watt for our LTE. We're not doing 100 watts like the cell phone companies are, but we're still able to provide pretty decent service out of that 1 watt with decent antennas. And the like. So, but I mean, a core site, let's say a hub site, may run 120 watts or so. It's easy to do battery backup with something like that.
Help me understand. I guess there's a difference between how you treat infrastructure that is tower to tower, backhaul, if you want to call it that. Maybe you've got a better word, and then the radios that actually service the customers, their customer premise, or their CPE equipment. Tell me about the delineation there. I'm guessing, if it's got a dish, it's your infrastructure, and if it's a sector antenna or an omni antenna, it's feeding customers. Is there more to it than that?
Typically, the radio that's feeding a dish, or the backhaul, we call it backhaul as well. The backhaul radios have a lot more processing power in them, because they're handling. We've got one backhaul radio that's handling 3/4 of a gig. And handling probably 400 simultaneous connections. So you're going to need to have a lot of processing power to run that all through, versus an access point where it's maybe connecting to 20 customers. There's not as much processing power going into that. So the infrastructure radios are going to be more power hungry, more processing power hungry, and the access points are just kind of loafing along, if you will.
Are all your access points sectorized with like 120-degree antennas, or what's a typical setup? How do you decide what antennas and radios to use for the access?
Well, we made a choice to go with horn antennas versus sector antennas, because the footprint. I mean, a sector antenna is 3 feet tall, and 8 inches wide, and if you have to put those back to back, their front to back ratio is not as good as horn antennas, and the horn antennas are literally about the size of my hand. Is that big around, and the 90 degrees are that deep, the 30 degrees are that deep, and so you can interweave these things all around each other without interfering with each other. So we've made that decision to go with horns. Now, horns don't have as much gain, but they make up for it in lower noise. So you still maintain that signal to noise ratio. So we're doing customers 6 miles out, line of sight. We've actually done in our LTE, we've done a couple 5 miles out, non-line of sight, which that's amazing to me, that you can shoot through trees 5 miles and still give them a 25 meg signal.
Wow. And again, what frequency band is that? Were you shooting through some trees and it works?
Shooting through trees is 3.5 CBRS
okay.
LTE. That's the LTE stuff that we're using.
Okay.
So that's the radios that have SIM cards, and just kind of, it's kind of like a cell phone, big fancy cell phone radio.
I thought I read some headlines recently about the 6 gigahertz band getting opened up to some unlicensed operations. Would that affect you?
Oh, definitely. Matter of fact, we've got an STA that we're filling out for 5.9 gigahertz, which was given out temporarily for the COVID relief, and we're going to use that for some of the backhauls that we have right now. But the 6 gigahertz will be a very big help as well, because 5 gigahertz in some areas is very noisy and pretty full, and the 6 gigahertz will be a little bit emptier. A lot of our radios that we have right now will activate 6 gigahertz with a firmware upgrade. The antennas are set. The antennas will be able to handle that. Just a firmware update. Let me think about it. I'm pretty happy with that. That's going to work out real well. So we're real excited about the 6 gigahertz. We're very excited about the 2.5 finally opening up, as opposed to some of the cell companies have been just kind of sitting on it doing nothing. We're hoping that's going to open up, because we can run up to 10 watts out of a transmitter, as opposed to 1 watt in LTE, and we can run LTE on 2.5, and the range would be significant on that, and the penetration to foliage would be significant as well. So we're keeping an eye on that. Those are probably the two biggest coming out right now. So it's 6 gigahertz and 2.5.
So what kind of links are you, or what kind of customer links are you using the 900 megahertz? You mentioned that a lot earlier. And exactly what band is that? Is that the ISM band or something else?
Was it 910, 920, 9? Yeah, that whole area. It's the free band stuff.
Okay.
And it's kind of all legacy stuff that we've had. It was one of the WISPs that we bought had it running into. It was a place way out in the middle of nowhere. It was a country club that had absolutely nothing, and so the antennas are obnoxious and huge, and it's just okay. It's too variable. There's too much noise on there, and things pop up out of nowhere, and it's just not fun to work with. Some people have been looking at TV white space, which I'm not a big fan of, because the equipment is outrageously expensive. I'm not very comfortable with the propagation on TV white space to maintaining it, and of course we're still going through all the changes in the TV scenes with the what's the term I'm looking for? Changing of the thank you, repack. With the repack, because one day your channel's good, the next day, maybe not so much. So some people are using that. I'm not seeing it yet, to be honest with you. So,
wow. Hey, Chris Tobin, please jump in here. I was thinking about the efficacy of 5.8 gig in an urban environment. Is there any way to make this work? I mean, are there antennas that just give you, hey, look, I'm focusing like this over at that building 2 miles away? Is there any technology that helps make 5.8 gig work in an urban environment where you've got a lot of Wi-Fi everywhere?
Well, let's see. A few things I've done on a couple of wacky projects. Horn type antennas that I've fabricated or found that worked. Modulation schemes that were a lower rate, so I can overcome the Shannon formula. And let's see. Basically, signal to noise. The key was the bit error rate, minimizing that. It's worked in a couple of places, but the 5.8 Wi-Fi or the the RF contention in areas around here is very high. I mean, the Max Connect router that I've been using and practicing some things with, when I look at the Wi-Fi contention on that, in most places it's 70%. So if I'm about 5 feet, 10 feet away from the router, the Wi-Fi pretty much falls apart on the iPad.
We actually have a Wi-Fi hotspot set up in downtown Charlotte, and that hotspot can see 90 different access points because it's all around by a bunch of condos. So it's competing with 90 other access points to try to provide internet service to a park in downtown Charlotte. So we're trying to find a different way of being able to provide internet to that park. But Ubiquity's got an interesting little radio that will do, half a mile or so. It's on 60 gigahertz, and literally it's this big. It's a little 60 gigahertz dish that has a built-in. Yeah, we just deployed one. So it's got 60 gigahertz. It'll give you a gig, but it's also got 5 gigahertz backup in case it rains or snows too much, you start losing your connection on 60. It'll roll back to 5 gigahertz and still give you about 150 megs.
Yeah, I've used the Ubiquity stuff in a few places where technically it shouldn't have worked, and it did. I will say that their design and algorithms, and the fact that the software tells you a lot about the signal integrity, more than just a bar graph, helps a lot in designing the link. And last 3 summers built out an internet service for a nonprofit, and we've done some crazy things in the absence of vertical assets by using trees and things as tower supports. It works. And we had one, and we managed to get 2 terabytes of data throughout the network on an anniversary weekend. So they were quite happy with the way we designed it. And it was interesting, I will say. A 5.8 microwave, you got to be an RF person and understand. Just because it says on paper it should work doesn't have to be the case. But we used 900 meg, 2.4, and 5.8, and it made it all work.
Kent, I've got a friend who asked me last week about, he doesn't have line of sight for his 5.8 gig shot, but he does have a big honking one of those flat, fat water towers, and he can see it quite easily from both ends of his hop, and his hop is a mile or 2. It's not long. Can he bounce 5.8 off the water tower? Would that?
It's worth a try. It's worth a try. Yeah. Good luck in engineering that. You're going to have to get your slide rule out for that one. But I don't see why you couldn't give it a try. Take a couple of dishes and point it up and see if it'll work. That's the best I can give you in that one. But we typically use those water towers to mount radios on. But I have not bounced off of one of them yet. Well, of course, we've seen the passive. We've seen the passive microwave sites that would use 2 gigahertz back in the day. I mean, those work great. So why wouldn't this work? I guess. Depends on
Chris, I think you've bounced some signal off Manhattan skyscrapers in your day, haven't you?
Well, yes, I've done that. 7 gig, we've done it with a couple of directional antennas, and 2 gig as well. And I've done a couple of 5.8s in Times Square, which actually worked. I wasn't looking to go a mile, but the fact that you're in Times Square and you're actually running 5.8 and doing a broadcast was actually pretty fun. It did violate all the rules of RF as far as the books are concerned. But a friend of mine who's a retired microwave RF engineer looked at it, took out his slide rule and his calculator. He's like, you know what? It can work. Wow, this is pretty cool. And we started doing some funky stuff with bouncing signals. It worked. But you got to really be passionate about this stuff and be willing to look beyond the boundaries. That's
right.
I mean, Oh, go ahead.
No, I'm sorry. I have a lot of mapping programs that help me design some of my links, and here in North Carolina, the tallest mountain east of the Rockies is Mount Mitchell, which is like 6,300 feet or 6,400 feet or something like that. A building in the town I live in, at the top of the building, I can see that mountain from there. So I thought, let's give this a try. Let's just see. And according to the link modeling, I could get 150 megs to that 6,400 foot mountain at 120 miles and give them 150 meg service. That's what it says on paper. I'm not quite sure if that's going to be real in life, but it should be fun to try.
Yeah. Well, I did a link, a proof of concept link about 3 years ago for this location upstate in New York State here. And according to several programs, mapping programs I was working with and a few people. They said it's not going to work. You can't get the 5.8 across 3 miles of trees in this place. I was like, yeah, but he goes, no, Fresnel zone. You can't do it. The Fresnel zone's blocked. I was like, well, but the primary RF path, okay, is not blocked. It skirts across the top of the trees. And they said, yeah, but the Fresnel doesn't, so therefore you got to have a problem. I said, yeah, but the principles of Fresnel is the negative return and the canceling of the main signal, or multipath if you want for a shorter term. Yeah. What if I push the Fresnel zone into the treetops and it can't bounce back up into the main beam? They scratch. Like, well,
good.
I could tell you 3 years later, that link is 3.5 miles and passing 500 megabits of data symmetrical and has not dropped out once. But if you take the antenna and tilt it up a little bit too much, guess what? It goes bit error crazy because now the Fresnel is being exposed. Bring it down, and the Fresnel's into the treetops. It's perfect. Brought in a microwave guy because a friend of mine did it for a living. Mapped it out. He says, "This is absolutely correct. This is pretty wild." So we built 3 more links doing the same method, and we now have a 4-hop microwave going around a 12,000 square acre facility and trees and hills and lakes, and it's working. So
that's awesome.
I'm just looking. You got to look outside the box. Kirk knows. You got to look outside, man. I'm telling you, this technology, Ubiquiti, and a few other companies, Ceragon and the others, they have maximized the principles, the physics of what you can do. And the antenna design is even better. I've looked it up on a couple of websites and at the FCC ID listings to look at their patterns and how they designed it. It is spot on. It is something you can, if you understand the principles, you can build some nice links. And that's what I've been enjoying.
These horns that we're utilizing right now are actually, you twist the radio right on. It's a company called RF Elements, and their patterns are really fantastic. And they've got an adapter where I snap the radio in and then twist it on, and there are no leads to go into the radio. So it's fed directly out of the radio into the horn, so there's no lead loss or no potential breakdowns, which anything that I can eliminate potential problems, I'm all about that.
Yep, that's exactly it. I've worked with those horns.
I'll provide a link in the show notes to the horn antennas from RF Elements. That's going to be, I don't know anything about those, so I'd like to read up on how those work. Hey, I got to tell you, friends, I've been doing the show today from Isle of Palms in Charleston, South Carolina, and I've been coming to you exclusively on the Max Connect wireless. And we're going to take a quick break here and tell you about this. Once again, I failed to tell the guest about something they have to do. We do a tip of the week. We do a tip of the week at the end of this announcement. And so, Kent, I'd love it if you could come up with a tip that our listeners could take home, and maybe a website, maybe a technique, maybe something they need to read, or a video they need to watch, or whatever it may be, something people could take home and put their pipe and smoke it, so to speak. In other words, get some use out of it. So you've given a lot of great advice. Maybe you get one more tip at the end of the show here. And Chris will probably have a tip too. My tip is this: Max Connect wireless.
Let's fix that. Oh, well, that's Max Connect. Well, yeah, he probably moved it. He should have done, because remember, it's wireless, and once you get a position locked in, you leave it there. But I've been using Max Connect the last couple of weeks for some projects, and we'll be talking about that in the weeks to come. And actually, it's pretty wild. The way you can use it, and because of its prioritized packet structure, I guess that's probably the way to put it, it gives you a better chance. So if you're not familiar with it, cell sites have various priority levels for access, user access, we'll call it that. And the first one is first responders, life safety, all that stuff at the top. Then there's a second level, which turns out to be one that the carriers can offer to customers, which is where Max Connect sits, which is a prioritized static IP. And it gives you priority over those like me using my cell phone on the same tower site. So I'm third on the list. So given a choice between 2 and 3, guess who gets it? 2. So that's what Max Connect offers you in a nutshell. It's real straightforward. And the nice thing is, because it doesn't require a special router, it's the account that you have. You could use the Cradle Point services that Max Connect offers, and I think now they're looking at PepWave. I hope I got that right. They have another product, another company manufacturer that makes a very efficient, very small form factor router wireless device. It's very handy. And a friend of mine uses the Max Connect, and he's been using it quite often, and I believe he's using it tonight for one of his shows. And So far, it's been unbelievable. Now, remember, if you're in a place where cellular service is spotty, your service will be spotty too. The box doesn't create RF signals. The Shannon law doesn't suddenly become null and void. If it's not there, it's not there. It doesn't matter. Just bear that in mind. What did you do to knock out the signal?
Apparently I must have yanked on a cable or something. It's my bad engineering on my fault, but not on Max Connect Wireless's fault. We got good bars here and did a lot of testing before the show, and obviously we went for over an hour with video both directions, about 5 megabits per second without dropping things. So remember, Max Connect Wireless, yeah.
I was going to say, with the Max Connect wireless router, you can log into it and see your signal strength, so you know whether or not you're on a marginal connection or not. So that helps. You can map it out.
So most people are using this for audio. So they're running, 2, 3, 4, 500 kilobits per second through it. And the point here, though, is that it is prioritized data. Not because it's a cradle point, because they have other routers, wireless routers available, but because it's Max Connect. And Max Connect Wireless has agreements with AT&T, Verizon, and with T-Mobile. So whatever your carrier of choice is, whatever one you think serves your area better, you can look at maps, you can talk to Max Connect Wireless about, hey, what's going to cover best in the areas where I'm trying to do remote broadcasts in. And there are now, Josh Bone has done a terrific job of getting the word out there. There are now literally hundreds of these at U.S. transmitter sites. There's a bunch going into our neighbor to the north in Canada. And radio stations are using these also for broadcasting from home for home-based talent that can only get DSL. They don't have good, reliable service, or they're trying to, make a hotspot with their phone, and that's not working too well. So, hey, if you can't get fiber, if you can't get cable, if you can't get wired, if Kent Winrich can't even get a internet signal to your place, that would seem unlikely. But if you can't, check Max Connect Wireless. I love this stuff, and Chris Tobin does remotes with it all the time too. MaxConnectWireless.com. It's spelled funny. We'll put the link in the show notes. Thanks a lot, Josh, for sponsoring This Week in Radio Tech. All righty. Kirk Harnack and Chris Tobin with you here, and Kent Winrich is our guest. Kent, may I put you on the spot for a tip of the week for our listeners?
Yeah. Let's try this one. It's in beta right now. The best mapping program that I've seen right now for doing links and coverage and the like, since Google has probably the best clutter data available, say doing all the flying over and the like, they've got something called Network Planner. wirelessconnectivity.google.com. You have to sign up for it, and they have to, I think, genuflect in front of a couple of people at Google to get connectivity to it. But we found it to be one of the best mapping and link programs because of the clutter data that's available, trees and buildings and the like. As a matter of fact, sometimes you can see shadows from church steeples and the like. So it's in beta, it's being tested, but you may be able to get some early access to it like we did.
It's called what now? Wireless what?
wirelessconnectivity.google.com. Network Planner. If you just Google Network Planner, it'll come up.
Gotcha. Okay. Google Network Planner. I will put the link to that in the show notes. And again, like I said, you may have to do some genuflecting to get that done.
Yes.
Thanks for it. Is Chris there? Or is he gone?
Sorry about that. I'm here, tip of the week. Let's see. Well, two things. Since we've been talking WISPs and wireless and RF and all those things, maybe it's time for all of us to start taking a look at our STLs. Let's see what's working. I know many of us here in New York City, there are several 1123 and higher gig links that are licensed that are operating point to point. Maybe time to take a look. Make sure the RSSI is where it should be. Check the connectors if you have access to the antenna itself. If it's on a parapet or a setback at your office or a transmitter site, or in this case, one of the building tops. And the other thing to do is, on those late nights when you're working hard, you've got to make sure you have a thermos, right? This is a simple modern 12-ounce Scout, and then it's great. It's you just pop the cover and you go. But the best part of it is, you screw it down, tighten it. It stays warm for several hours. I've done this, believe me. And the best part is it doesn't leak, so you can put it in your bag.
Oh,
look, you see?
Oh, perfect.
Look at that. Yeah, it's great. I travel with it all the time, and I can go about 4 to 5 hours, and it's still warm and enjoyable. So those are two
what
things.
brand is that
Check
again?
out that STL link. It's called simplemodern.com. This one is the 12-ounce Scout and wash only.
12-ounce Scout.
It's good stuff.
Good for iced coffee too.
Oh, absolutely. Unless it has to be hot. It could be cold. You could mix it with other drinks of your favorite. Who's the question?
I don't recommend climbing a tower with a margarita, but wow, good deal.
Well,
and hey, my
Camelback, you'll be fine.
Camelback, there you go. My tip is to remind you to go sign up at nautel.com/webinars, because Tuesday, June 2nd, next week on Tuesday at noon Eastern, that's 9 a.m. Pacific time, you're going to want to attend their storm season with an exclamation point, because it wouldn't be a great webinar unless there was an exclamation point after storm season. Jeff Welton is going to be there. Jason Goroditzer is going to be there, and Shane Tovin are going to be there talking and helping us prepare and recover from bad storms. Tornado season, and hurricane season starts up. Hey, we got to go. Kent Winrich, thank you for being on here. It's been a real delight, and I hope to have you on again.
Thank you very much. Anytime. This is always fun.
And give my regards to your family. I know you post sometimes family outings with the wife and family, so great to see all that. Yes. And you guys are just terrific. You uplift our spirits.
Thank you very much. Appreciate it.
And Chris Tobin, thank you for being here too. Thanks for joining us from Manhattan or wherever you are.
My pleasure. No, my pleasure. It was great. I enjoyed this, and Ken, was excellent having you on. And I hope all of the audience has enjoyed some of the knowledge you've bestowed upon people, that you don't have to be wired only to make things happen.
Hey, so during the broadcast, have you been hearing the lawnmower that's going on behind me? Have you heard that? Is it loud or not? Is it just me? No,
I haven't noticed it much.
Well, I'm using a very directional microphone. Yeah, I do. Yeah, exactly. I didn't bring it with me, but my friend Roger has the Sennheiser MKH416, so I've been using the shotgun mic and close talking. But yeah, there's a loud lawnmower here behind, and of course it was quiet here all afternoon until the show started, and then the lawnmower started. Thanks so much
it's part of being on location.
Next week, Chris, we're going to make a trip to Cadiz, Kentucky. And there is a museum there at a radio station. And the museum has lots of old radios. We're going to be talking to Beth Mann. She is the manager of the station. She may also be the owner. I'm not sure. She's also a business partner with me and 40 other people at a radio station in Hawaii. But she has put together, along with others, this beautiful museum of old radios. We're going to go visit that, do a live broadcast from WKDZ and their old radio studio. So I'm looking forward to broadcasting live from there. Thanks to Suncast for producing our show. Really appreciate you and the magic you work every week. Thanks also to Andrew Zarian for being the founder of the GFQ Network. We got to go. We'll see you next week.